So suppose that H and K are subgroups of G, then HK is a subgroup of G if and only if HK is equal to KH. So assume that HK is a subgroup of G. So let G be any element of HK then we wish to show that G is also an element of KH. So since G is in HK, G is equal to HK for some H in H and K in K. And since G is in HK, G inverse is also in HK. So G inverse is equal to H prime K prime for some H prime in H and K prime in K. But then G inverse is equal to G, which is equal to H prime K prime inverse, which is equal to K prime inverse H prime inverse, which is then in KH. So HK is equal to KH as desired. For the backwards direction, assume HK is equal to KH and let X, Y be in HK. We want to show that X, Y inverse is then in HK, which by the subgroup criterion would show that HK is a subgroup of G. So let X equal HK and let Y equal H prime K prime. Then XY inverse is equal to HK H prime K prime inverse, which is then equal to HK K prime inverse H prime inverse. And notice you can now group this K and K prime inverse together as one element. In particular, here you get an element in K times an element in H. So this is then equal to H double prime K double prime. Where did that come from? Since this is an element in K and this is an element in H, it is in KH. And by assumption, any element of KH is in HK. So this element of KH can be represented as H double prime K double prime. And now this becomes H double prime K double prime, which is an element of HK. So HK is a subgroup of G.